Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today we are going to study a numerical problem number 1, which is based on solution of differential equation using inverse Z transform. Now, in these first two numericals, what we are going to study a transfer function of a system, impulse response of system and step response of system. But while solving this equation, what we are going to do, we are going to assume all initial conditions are 0. Then you can get this answer of all these three questions. So we will move on to question number 1 first. Problem number 1. A system is described by equation. This is the differential equation. The y of n plus 2 plus 4y of n plus 1 plus 3y of n equals to x of n. And what we are going to calculate, a transfer function of system, then impulse response, and the last one is step response of system. So we will first of all calculate, or we will apply a Z transform on both the sides. So we will solve this question by applying Z transform first. Now, this is our question. Basically, to calculate the first part, that is a transfer function, we will apply Z transform both the sides. But while applying a Z transform, we are going to assume all the initial conditions for y of n plus 2, then y of n plus 1 are 0. So simply we will apply a two-sided Z transform property on both the sides, or we will use a two-sided Z transform property or time shifting property over here. Now, basically this y of n is delayed by 2. So as I said in properties also, if the function is delayed by 2, then just do one thing, place this whole delayed value or advanced value in the power of z with a sign, and that value of z is multiplied with the z transform of y of n, or with that function. So look at here, the y of n z transform y of z, but the z or this delayed value is placed on the power of z with a sign. Now similarly, here the 4 is a constant, then y of n plus 1. Here the y of n z transform y of z, but this delayed value is placed in the power of z. So that's why I multiplied this 4z with y of z. And the last one is y of n. The z transform is y of z. And the last one is x of n z transform is x of z. Now what I'm going to do, I want transfer function, which means the ratio of z transform of output response or output to the z transform of input. So first of all, I'll take y of z common from left hand side. So after taking y of z common, I have got this equation z square plus 4z plus 3. And now I'll take the ratio to get the transfer function. So y of z by x of z is nothing but transfer function of system, and it is represented by x of z. And then we'll shift this product part on right hand side, so it will be in a denominator, and what you will get, 1 upon z square plus 4z plus 3, and I'll mark this is nothing but my equation number 1, because I want this equation for next further calculations. So second part is impulse response, so we'll go for the second part. Now the second one is impulse response. How to get the impulse response? The output response can be considered as impulse response if and only if you apply input as a impulse function. So if I consider my x of n is del of n, then after substituting the z transform of x of n in my equation number 1, whatever outcome you will get after applying inverse z transform, that outcome is nothing but the impulse response of system. So first of all, I will apply z transform on this. So z transform of x of n is represented by x of z, but z transform of del of n is del of z, and we know the value, it is 1. Now we will use that equation number 1. So this was our equation number 1. Now what we want, impulse response, which means we have to substitute x of z equals to 1, and this x of z I'm going to shift on right hand side. So your y of z becomes, now substitute my x of z value in this function. My x of z value is 1, so I'm going to substitute over here. So what I can write, what we want, impulse response, that is inverse z transform of y of z. But we cannot apply inverse Z transform on right hand side, because first of all we have to factorize this denominator. So What are the factors you will get? Look at it, the last term is always product of two digits, whereas the midterm is always addition of similar two digits. So let's say if the last term is a product of two digits, that is a 3 into 1, you will get the 3. So my two different values are 3 and 1. And if we add both these values, then you will get the midterm, that is 4. So 3 plus 1 is 4. So I can say that my factors are z plus 1 and z plus 3. My factors are z plus 1 and z plus 3. But whenever a function is a normal z, then we will always divide both the sides by z, or else you can say that multiply numerator and denominator by z on right hand side, and then I'll shift that numerator z on left hand side. You will get the same equation if we do the division, or you can say that if we divide both the sides by z. So first of all, I'll divide both the sides by z, and then we'll go for partial fraction. So here we can use three different constants. So let's say my constants are a, b and c. So we'll write in the denominator of a, we'll write z only. Now let's say this is nothing but my equation number 2, and I'll multiply this left hand side denominator on right hand side. So what you will get? And this is nothing but my equation number 3. Now I'll substitute the values or different values of z, so that you will get the constant value of a, b and c. So first of all, I'll substitute z equals to 0 in my equation number 3. If I substitute z equals to 0 in my equation number 3, then automatically this whole c term and whole b term gets vanished, because it is multiplied by z, and this z is replaced by 0. So 0 into anything, answer is 0. So 0 plus 0, answer is 0. So we will get the answer of only a. So if this z is replaced by 0, so we'll have only 1 and only 3 in this bracket, and 1 into 3 is 3, and if I shift this 3 on left hand side, what you will get? A value becomes 1 by 3. Now similarly, we'll substitute z value to get the value of b. What I can substitute? I'll substitute z equals to minus 1 in equation number 3. If I substitute z equals to minus 1, then what you can say that if this z is replaced by minus 1, then minus 1 plus 1 becomes 0, and 0 into anything, answer is always 0. So I'll replace this whole a term by 0. Then look at here, this z is replaced by minus 1, this z is also replaced by minus 1, so I can write. Now we'll move on to next. If this z is replaced by minus 1 plus 1 becomes 0, and 0 into anything is answer becomes 0. What do you will get? 0. Now simply minus 1 plus 3 is 2, but 2 into minus 1 is minus 2. Now if I shift this minus 2 on left hand side, you will get b equals to minus half. Now we will go for next one, that is we will calculate the constant value c. For that we will substitute z equals to minus 3. If I substitute z equals to minus 3, then look at here. If this z is replaced by minus 3, plus 3 minus 3 becomes 0, and 0 into anything, answer is 0. So whole a term or whole this product term is replaced by 0. So I can write 1 on left hand side and 0 first. Then again, this z is replaced by minus 3 plus 3 becomes 0, and 0 into anything is again 0, and 0 plus 0 is 0 only. So we'll move on to directly see this z, and this z is replaced by minus 3. Now look at here, here we have minus 3, and here we have minus 3 plus 1. Minus 3 plus 1, answer is minus 2. Minus 2 into minus 3, answer is plus 6. So I can write 6c on right hand side. Now if I shift this 6 on left hand side, then you will get the value of c, which is 1 by 6. Now I will substitute all the variables value a, b, c in my equation number 2. So look at here, I have substituted all the a, b, c values in my equation number 2. Now we will apply z, or I will shift this z on right hand side. So what you will get? this z is shifted over here, so z is cancelled. You will get only 1 by 3. Now this minus half is a constant, so I will write minus half first. This minus sign is come because of plus into minus is minus, and this z is shifted over here, so you can write half into z upon z plus 1. Again this 1 by 6 is a constant, so I will write first, and then this z is shifted over here, so I can write z upon z plus 3. And now I can apply inverse z transform on both the sides. So after applying inverse z transform, what you will get? This y of z can be written as y of n. Now 1 by 3 is a constant, but 1 by 3 is a constant, which means a constant inverse z transform is always impulse function, that is del of n. Then minus half is a constant, and z upon z plus 1. Basically we have studied one formula, that is a raised to n into u of n. A z transform of a raised to n u of n is always z upon z minus e. Now here we can compare this equation with this one. So I can write my a value is over here, my a value is minus 1. So if I consider my a value is minus 1, then I can write minus 1 raised to n into u of n. Next one, this is 1 by 6. This z upon z plus 3 we have. Now here my a value is, I can say, minus 3. So I can write this formula as minus 3 raised to n into u of n. So this is nothing but the impulse response of system, and if you want, then you can take u of n common from last two terms, or else you can stop here also. But I'm taking u of n common from last two terms, so what you will get? Y of n is equals to and this is nothing but my impulse response of system. Both these answers are correct, so don't worry. Now we will move on to step response of system. Now, how to get the step response? First of all, to get the response, we need to apply, or we need to consider my input is nothing but my step input. So for that, I'll substitute x of n is equals to u of n, that is a unit step input. Now we will apply z transform both the sides. So what we will get? X of z is equals to z transform u of n is always z upon z minus 1. Now I'll use, or I'll put this value in my equation number 1 that we have derived in, or that we have calculated in first question, that is in h of z, or you can say a transfer function. So from equation number 1, I can say that my y of z value upon x of z value is, now I'll shift this x of z on right hand side. Now I'll substitute my x of z value, which is z upon z minus 1. So this z minus 1 will come in denominator and z will be in numerator. Now I'll shift this z on left hand side and I'll factorize the second part. The factors that we have already calculated, and the factors are z plus 1 and z plus 3. Now you can get the step response, but if we apply inverse z transform only on y of z. So to apply or to get the impulse response, first of all we will use a partial fraction method. As according to partial fraction method, if we have a 3 factors, then we will use the 3 different constants. So let's say my constants are a, b and c. So in the denominator of a, we will write z minus 1. Now I will multiply this whole denominator on right hand side. Then after, you will get the answer, or you can get the answer for constants a, b and c by substituting different values of z. So after multiplying left hand side denominator on right hand side, I have got this equation. Now simply substitute different values of z to get the values, or to calculate the values of a, b and c constants. So first of all, I'll substitute z equals to 1 in my equation number 5. If I substitute z equals to 1, then look at here, 1 minus 1 becomes 0 and 0 into whole term becomes 0. Similarly here also 1 minus 1 becomes 0 and 0 into whole term becomes 0. So automatically my b and c term, I'm going to replace it by 0. I'll calculate only the value of a. So on left hand side we have only 1, but on right hand side what you can say, 1, this z is replaced by 1. So 1 plus 1 becomes 2, and here 1 plus 3 becomes 4, and after that we're going to write a 0. Now 4 into 2 is 8, and if I shift this 8 on left hand side, we'll get 1 by 8. Similarly, I'm going to substitute z equals to minus 1, because if I substitute z equals to minus 1, then look at here, minus 1 plus 1 becomes 0, so whole a term gets vanished or replaced by 0. Similarly, look at here, if I substitute z equals to minus 1 over here, then minus 1 plus 1 becomes 0, and this 0 will be multiplied with the whole c term, and this will be also replaced by 0. So we'll get the answer only of, so I have replaced this whole a product term by 0. Then I'm going to substitute minus 1 in this equation. And as I said, my whole c product term is nothing but 0. Now minus 1 answer is minus 2, and minus 1 plus 3 answer is plus 2. Minus 2 into plus 2 answer is minus 4, and if I shift it minus 4 on left hand side, what will get? Minus 1 by 4. Now which term you are going to substitute in the place of z, so that you will get the answer of a constant c? Simply I can say that if I substitute z equals to minus 3 in this whole equation, then automatically this a term and b term replaced by 0, because we have a z plus 3 on both the sides. So as the z is replaced by minus 3, then minus 3 plus 3 becomes 0. Here also minus 3 plus 3 becomes 0, and 0 into whole term and 0 into whole product term becomes 0. So I'm going to write a 0, which is a product, or you can say which is the addition of both these terms. And the next term is c. Now this z is replaced by minus 3, so I'm going to write minus 3 minus 1 in first bracket, and then this z is also replaced by minus 3, so minus 3 plus 1 will be in second bracket. Now minus 3 minus 1 answer is minus 4, and minus 3 plus 1 answer is minus 2. And we know that minus 4 into minus 2 is plus set, and if I shift that plus set on left hand side, what we will get? C equals to 1 by 8. Now I'll substitute all this a, b, c value in my equation number 4, and then I'll apply inverse z transform to get the step response of system. So look at it, I have substituted all the values of a, b, c in my equation number 4. Now simply multiply this z on right hand side. So 1 by 8 minus 1 by 4 and 1 by 8 is a constant. So I'll write that constant value first. After applying inverse z transform on both the sides, what you will get? Y of z inverse is y of n. This 1 by 8 is a constant, so I can directly write 1 by 8, and z upon z minus 1 is the inverse z transform of u of n. Again minus 1 by 4 is a constant. Now here, as I said in previous part also, z upon z plus 1, here my a value is minus 1, so I can write the inverse of this is 1 raised to n, minus 1 raised to n into u of n. Again here 1 by 8 is a constant, and z upon z plus 3 we have. My a value is minus 3, so I can use the time scaling property over here. So I can write minus 3 raised to n into u of n. Now again, you can stop here also, or else if you want to move further, then you can take u of n common. So if I take u of n common, then the first term is 1 by 8. Next, here minus 1 by 4 raised into minus 1 raised to n, and in last part what I can say, 1 by minus 3 is to n left as it is. Now this is all about a step response. So the main thing is, while calculating a transfer function or the impulse response of system or step response of system, what we are going to assume, we are not going to count any initial condition. All the initial conditions we are going to assume as a or considered as a 0, and then you can get the answer for all these 3 questions. Now remember one thing, while calculating transfer function, impulse response and state response, always consider all initial conditions are 0 while applying Z transform on that differential equation. So that's all for now. Stay tuned to Ekeeda and subscribe to Ekeeda for further on videos. Thank you so much.